Good morning, everybody. See now, my dear friends, we shall now go to the another important chapter in your precious concrete. That is shear in PSC beams and its design. In the sense now, how exactly shear occurs in your precious concrete beams and how to design for the shear reinforcements. Okay, I think you have studied in your RCC. Okay, Bano, what should be done to take care of this shear in case of your RCC beams. Am I right now? So now I will just first explain you what exactly we used to do in our RCC. Am I right now? Say for example, here I have drawn one RCC beam, sir, now, wherein, you know that this is your main reinforcement. Okay, this is your main tension reinforcement. Am I right now? Then out of these main tension reinforcement, I may bend some bars up like this. Am I right now? I may bend some bars up at 45 degree. Say for example, if you have got 4 bars as your main reinforcement, I may bend 2 bars up. Am I right now? So these bent up bars you have seen in case of your RCC, that these bent up bars can resist the shear. Am I right now? This is one way of tackling the shear in case of your RCC beams. Along with that, okay, if the shear force is still heavy, okay, then we are going to give here the stirrups. Am I right now? These stirrups may be, Baba, now they are two-legged stirrups, or they may be three-legged stirrups, or they may be four-legged stirrups, etc., etc., depending upon the intensity of the shear. Am I right now? So now, in the cross section of this RCC beam, if I take a cross section here, you will see like this now. Okay, these are your main reinforcements. Okay, then we have got here anchor bars. This is your anchor bar. Okay, anchor bar is this anchor bar, and here now I have got two-legged vertical stirrups. Okay, a stirrup will travel from here, make a hook here, come like this, 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 and hook it here now. Okay, this is how the two-legged vertical stirrup will travel. Since it has got two legs here, I will call it as two-legged vertical stirrups. Okay, so now, Baba, in case of your RCC, you know that the stirrups are going to play an important role. Okay, it may be two-legged stirrup, or it may be four-legged, five-legged, six-legged, etc., etc. Okay, though, so now these stirrups and these bent up bars, okay, can effectively resist the shear. Am I right now? This is one thing. And also, you have seen that uh, your this thing now, what now, your shear is mainly due to the diagonal tension or the principal tension. Am I right now? So now, the instance now, your your shear force is going to be developed because of the diagonal tension, or it may be called principal tensile stress. Okay, so now if the principal tensile stress is very small, okay, if the principal tension is very small, then there is no need of any of these shear reinforcements, either in the form of bent up bars or in the form of vertical stirrups. If the principal tensile stress is more than the permissible tensile stress of the concrete, then Bano, you know that shear exists, and to resist the shear, I have to provide here the so now bent up bars as well as these vertical stirrups now. Okay, this is what we have studied in our RCC. Am I right now? And also, one more thing you have studied is now, even though principal tensile stress is, say now, well within the permissible tensile stress of concrete, or say assume that principal tensile stress is almost zero, or I say that if the shear is almost zero now, say, even then, okay, it is a customary practice to provide here the vertical stirrups. Your IS code says that minimum stirrups should be provided in your RCC beam. That is what your IS code says. Okay, so now accordingly, your RCC beam is going to be designed. Okay, so now this is all with respect to what happens or how do you take care of the shear in case of your RCC beams. Now we shall come down to your precious concrete. Okay, what exactly happens in case of your precious concrete? See now, in case of your precious concrete also, the same behavior exists. In sense now, in case of your precious concrete, also now, shear exists. In sense now, uh, uh, since the shear exists, I have to design the shear reinforcements. Okay, but in sense now, in case of your precious concrete, two factors are going to reduce the intensity of diagonal tensile stress or the principal tensile stresses. In a sense, two factors are going to reduce the shear, or they are going to reduce the principal tensile stress or diagonal tensile stress. What are those things? What are those two factors? It's very, very important. So please try to hear me. See now, the first factor is, okay, sir, now it is the slope of the tendon. Say for example now, okay, in case of a precious concrete beam, assume that I have laid a straight cable like this. I have laid down a straight cable. If I lay down a straight cable, so now what happens? Let us try to now see now first. See now, at section 1-1, I will take a section 1-1. Baba, it is in your precious concrete. Okay, it's a precious concrete beam. The cable is laid straight here now. Okay, and I have applied some preciousing force P. Am I right now? So now, at any cross section 1-1, that cross section I have shown it down here now. Okay, but now here I have got reaction RA. Okay, and along with this cable you have got a precessing force P. Am I right now? And here at this cross section 1-1, I've got shear in a concrete, VC. I've called it as VC. It is a shear carried by your concrete. Okay, sir, now so now here if I apply simple upper mechanics rule, sigma Fv is equal to 0. In the sense, all vertical forces should be equal to 0. I will get Vc is equal to Ra. Am I right now? Vc is acting in this direction. Ra is acting in this direction. So now Vc is equal to Ra. In a sense, at this cross section, okay, I say that the shear force carried by the concrete Vc is equal to Ra. Am I right now? The shear force carried by the concrete is equal to your reaction Ra. Is it right now? This is a very, very simple concept which you have studied in your upper mechanics. Now, let us consider another case wherein, okay, assume that I am going to lay down the cable in in a this thing now, in a what now, say curved fashion. Usually in case of your precious concrete, that you are going to lay down the cable, okay, parabolically like this. Am I right now? So now here what happens, let us try to see now. Okay, again, but now in sense now here let us assume that the cable is laid parabolically like this at some cross section 2-2. Say now what happens, let us try to see now. As usual, Baba, now I have got Ra, reaction Ra. Okay, and Baba, now since your cable is laid at some inclination, okay, P is acting in this direction. Your 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 precessing force P is now acting here, and now I am going to Baba, now what now, in terms of split up this, resolve this P force into two components. Assume that it is theta. Okay, this is P cos theta, horizontal component. Vertical component is P sin theta. Am I right now? I have resolved this P force, precessing force, into two components, P cos theta and P sin theta. Vertical is P sin theta. Okay, and as usual here your vertical shear force carried in the concrete, I have shown it as Vc. Okay, so but now I am going to apply the same sigma Fa is equal to 0. The same upper mechanics rule. Okay, vertical force equal to 0. So now here what happens is now, see now, if I apply the rule, Ra is acting in this direction. Assume that this direction is plus Ra. minus VC, because VC is now acting down, so it is minus. P sine theta is now also acting down. Am I right now? Minus P sine theta equal. This should be equal to 0 now. Okay, summation of all the vertical forces should be equal to 0. Am I right now? So from this equation, if I want to calculate VC, okay, it is RA minus P sine theta. Okay, RA minus P sine theta will give me VC. Just rearranging these terms. Okay, so now what you are going to see here is now, okay, shear force carried by the concrete here is RA minus P sine theta. In the sense now, in the last case, it was how much now? VC was equal to RA. Am I right now? When the cable was straight, VC was equal to RA. When the cable was straight, okay, the shear force carried by the concrete is exactly equal to RA. But now here, when the cable is laid little inclined, okay, when the cable is laid inclined fashion, okay, now you know that the shear force carried by the concrete is given by RA minus P sine theta. In the sense now, VC is reduced. VC is reduced by P sine theta value. Am I right now? VC is reduced by a quantity called P sine theta, where P is the precessing force applied and theta is this angle. In the sense, what I mean to say now by this example is, whenever we lay the cable inclined like this, okay, the inclination means theta. Am I right now? Whenever I lay the cable inclined like this, your shear force carried by the concrete is going to get reduced by a value called P sine theta. Am I right now? Say for example now, okay, if this P sine theta value goes on increasing, or if I go on increasing this theta value, if I go on increasing this value of P, also precessing force P, Baba, until this value becomes RA, Baba, when this becomes RA, RA minus RA will become 0. Am I right now? In the sense, the shear carried by the concrete is 0 now. In the sense, there is a possibility. In the sense, there is a possibility that when I go on increasing the value of P and theta, okay, I may reach a stage wherein there is no shear force in this concrete at all. Okay, I can reach that stage also. Baba, that is the beauty of this precious concrete. In the sense, whenever you apply a precessing force with some inclination, okay, it is an advantage. It is an advantage. Am I right now? So now, this is the first factor which is going to reduce the your shear in case of your RCC, in case of your PSC beam. Okay. Now the second factor which reduces the diagonal tension or shear is, Baba, it is the introduction of the compressive stress by the pre-stressing. Am I right now? But now since you know that in case of your pre-stress, I'm going to apply a pre-stress by means of applying a compressive stress. Am I right? Whenever I apply the compressive force to the beam, automatically your tensile stresses are going to get reduced. So now diagonal tensile stress is going to get reduced. So now these are the two factors which are going to play an important role in our precious concrete beam. Okay. Thank you very much.